All right. Welcome to lecture number 2. We'll record lecture number 2 over semi-advanced topics in game development on PICO-8. This lecture is going to be about procedural generation and some ancillary stuff that goes along with it, like dealing with level transitions and such within your code. So, first things first, what do I mean by procedural generation? If you've played some of the more recent games that are out there in, especially indie games, a lot of them rely on this thing called procedural generation, which has been around for, to be honest with you, a long, long time. Basically, it means that I'm going to use an algorithm to generate something that's part of or follows some set of rules. We've been using algorithms for this for a very, very long time, generating sequences of numbers. And to be honest with you, like even pseudo-random number generators are procedural generators. When we talk about it from sort of a game design perspective, we want things that generate certain aspects of our games. The most common, oldest procedural generation, if you will, that sort of applies to game design is the procedural generation of levels. And this was first really popularized in a game called Rogue, which is basically a dungeon delver, which auto-generated levels using sort of a random key set. But this can be way, way more than levels. This could be talking about generation of enemies, especially if you have sort of RPG elements where you have stats. You can randomize those stats and procedurally generate NPCs that way. There's several games that do that. But for the purposes of this lecture, I'm going to talk about procedural generation in somewhat simplistic terms to get it basically through the lecture, and then we'll talk about things that we can take from that and then advance on, iterate on afterwards. So I'll take you, like 65% of the way there, and then you can take it from there depending on what you want in your game. All right. So the big pro here for PICO-8 is that since I've got such a limited amount of memory and I've got such a limited amount of space on the map and on the number of tokens that I have, procedural generation can work really, really great for generating many, many different dynamic levels without the extra cost that would be sort of required in order to do this sort of thing by hand. The basic principles are this. What I want to do is identify the elements of my levels that can be randomly placed, figure out the probability of those elements occurring in my level based on the design, figure out what rules I want to have in order to guide placement, and then put it into code. So the very first thing that I want to do is a very, very basic top-down room generator. Note that I have everything mapped out either as a 0, which is collidable, or 1 that's not. That's, to be honest with you, that's not going to matter too much here. But what I really want is just a way to sort of generate a very, very basic level without any worries about stuff that I could run into. So let me load here my lecture 2, and this is my load from. This is the same basic setup as I had with my previous lecture. So I've got my little guy here, and just a very, very basic setup as far as a border. Just using the whole screen here, 128 by 128, but nothing more than the screen. And what I'm going to do is I'm going to fill this in with a bunch of these sprites down here, these wall sprites, and handle that in some way. All right, so let's pop back over to my code here. So this is the same basic code that I've got set up here. And so what I want is to basically go through my level in a clean pass, going from tile 2-2. Do I want 2-2 or 1-1? Well, we'll try 1-1 here. I'm not yeah, we want 1-1 because the pixels are oriented from 0. The table's oriented from 1. So I'm going to start off by creating a table called tiles, and we use tiles before as sort of our holder for our walls. And then I'm going to create a function here called genLevel. And genLevel basically sets up as a big for loop, and the for loop says for I equals 1 to 14 do, because I'm going to go from 1-1 to 14-14. And for j is equal to 1 to 14. So I want all of those. Let me hold up just 1 second to talk about why it's 1-1 to 14-14. Because we're going to be looking at these as tiles, 8x8 tiles. I need to divide my space into 8x8 tiles, which means when I take the 128 and 128 pixel width and depth that I've got, I'm going to actually change that into basically 16 by 16. Since we're framing everything from 0, that's 0 to 15 inclusive, but I've got that border, and so I don't need the, I want to exclude that border. So 1-1 to 14-14. And within my for loop, I'm going to actually create my randomizer. So I'm going to say if random of 10, and floor that, because the random number generator in Lua will actually give you a floating point number. If that is equal to 0, and I don't want something in 1-1. So I want I not equal to 1, and j not equal to 1. So I don't want anything in that 1-1 corner there, because if I do 1-1, then it's going to try to put a wall piece over the top of my player, and I don't want that. Then I'm going to set up a temp here. Temp is empty. Then temp.x is equal to I. Temp.y is equal to j. And temp.s, which is just telling me what my sprite is going to be 2. And then I'm going to, as part of this, add temp to tiles. And this provides a nice deep copy way of adding that stuff. And. All right, great. So this should generate a nice level that gets me basically 10% of my tiles are walls. All right, so let's see. Well, let's just adjust our draw function here to make sure that we handle that. For I in all tiles do, and then this is just going to be my sprite call. I.s, I.x, I.y. And all right, so let's take a look at this. Got here, do load, lecture 2, run it. There seems to be a problem. I have no walls. So what did I do wrong? Well, this is an easy fix. What I did wrong was I have my draw correct, I have my gen level correct, but I didn't actually call gen level anywhere. This is where init actually comes into play. So we haven't been using init basically at all up to this point. But in this case, I really needed to actually generate a level for me. So I'm going to do gen level here as part of init. This will run at the very, very beginning and then actually generate my level for me. Switch back over, load, run. Oh, that's not good, is it? That seems to be all clumped up. Made yet another mistake. Very, very silly of me. In my draw, I've got I.S, I.X, I.Y, but I.X and I.Y are tile width. So I need to multiply these by 8. That way they're not all clumped together. Very, very strange. Go the other direction. Load, run. There we go. Now I've got a nice auto-generated level. It changes every time. It should be roughly 10%. Sometimes going to be a little bit more. Sometimes going to be a little bit less. But nice and clean. Great. Okay. So, we've got all of that taken care of. One thing to note here, let me go back to this real quick, is we're missing our collision, right? Our collision from before, all map-based. And so I don't want to do map-based collision here because I'm not using the map. I'm actually doing sprite-level drawing. Now, you can, using mset, actually create the map as you're generating these tiles, and then you can still use the bump function that we've already got to actually do that. But we're not going to do that here. What we're going to do instead is go back and just write a little thing for our collision. Just run through those tiles and just check for collisions within each time that I'm actually doing my move. So in here, instead of using my bump function, actually we'll do bump here. We'll do bump. We're going to take this return fget mget function out because we're not going to use it, and we're just going to say for I in all tiles do if I.X times 8, again we need to make sure that we're multiplying by 8 here, is less than or equal to x, and I.X times 8 plus 7, we'll talk about why that plus 7 is there, it's greater than or equal to x, then check the y. If I.Y times 8 less than or equal to y, and I.Y times 8 plus 7 is greater than or equal to y, then return true. And. All right. Let's run this real quick. Check to make sure that it actually works correctly. Perfect. Nice, clean collisions here. A couple little bumps here, but nothing major. Now, if you remember from the AI lecture, we used bounding boxes to detect the collision between two entities. You can use the same thing here, but actually note that what we've got is more or less the same sort of thing. I'm checking all of the borders from both my player sprite and all of my tile sprites and detecting if there's a bump there. When you have this plus this here, then you get all of the borders. It's up to you which way that you go. For me, if I was incorporating both of those two things, which I may do a little bit later, what I would actually want is just that bounding box. But for this works just fine. Okay. That's all great. So I've got I have now procedurally generated a level. Fantastic. Okay. What I want now is I want this to be game-like. So I'm going to actually create a goal. And I sort of hinted at this earlier in the previous lecture where I'm talking about that little present sprite. I'm going to use the present sprite here to generate a goal for my present. And so I'm going to have, just in here, goal, another table. And then within gen level, I'm going to set up a boolean, k is equal to true, while k do I is equal to floor rand 5 plus 10, j is equal to floor rand 5 plus 10. And so what I want is I want my present sprite to actually show up in kind of the bottom right corner of my level. And but once I've generated I and j here, I need to actually check to make sure that I'm not trying to draw the present on top of a tile, on top of a wall tile. So I need to do that check now. So for q in all tiles, do if I is not equal to q or j is not equal to, I need that to be q.x, j is not equal to q.y, then I'm clear, right? I can do goal.x is equal to I. Fill. Okay. Goal.y is equal to j, and then I can set my k here to be false. And then I could break out of my for loop. And. All right, perfect. And so now that I've got that, I got to draw the sprite. So all the way down here at the bottom, SPR, and my sprite here is 0, 1, 2, 3, 4, 4, goal.x, goal.y. All right, let's run this. Load, run. Oh no, I did it again. Oh, jeez. This is what I get for doing this at midnight. All right, save that. Screwed it up again. Load, run. There we go. And now this shouldn't be in any sort of way attached to a tile. So let's run it again, run it again, run it again, run it again. Perfect. Okay. So now that I've got this, what do I want? Well, I want the level to transition every time that I hit my goal sprite. So I'm going to create a little function here a little bit later, in just one sec, once I stop messing around with this. I'm going to create a goal check. I'm going to create a function called goal check. All right, so let's put it right here. Function goal check. And basically goal check just does one thing. If px is equal to goal.x times 8, and py is equal to goal.y times 8. Then, what do I want to do? I want it to automatically reset px to 8, py to 8, and then I want it to run gen level again. That's it. Easy peasy. All right. Let's see if I actually got this right this time. Run. All right. So if I cover the sprite, It should automatically generate stuff. Uh-oh. Uh-oh. What's going on here? Yeah, of course I would screw something up again. I actually need to run goal check here as part of my update function. So, right here, all the way at the end, goal check. Alright. Now this should work. Come all the way down here at the bottom. Bam! Uh-oh. What's going on here? I seem to be having some sort of problem. I mean, this is an interesting level of additional complexity for all of my levels, but I don't think this is actually what I want, because eventually I'm going to get to the circumstance where I can't get to my goal. So what's happening here? Well, as part of my goal check, as part of regenerating my level, I don't actually clear the tiles that I've already created. So all the way at the top of gen level here, I'm going to do one more thing. Tiles equals empty. And what that will do is just regenerate and clear tiles. It will just set tiles back equal to an empty table, at which point I can now go through here and actually have my level set up the way that I want to. If I can actually get this. Oh no. So obviously the collision here is not precise. Well, it's actually too precise, really. So again, you could use the bounding box stuff from the AI tutorial if you would like, or you could build a slightly more robust collision detection here. That's up to you. All right, that's great. So what's next? So I've got procedurally generated level. I've got my goal set up here. But one thing to note is that this is kind of sparse. And while this is fine, it pretty much ensures that I'm not ever going to run into an issue where I can't actually get to whatever my my goal here is. This isn't great, especially where I'm not actually doing any enemies. So what can I do instead? Well, this leads into sort of an extra, some extra stuff I could actually build into this. And so what I'm going to do now is actually bump this up, bump this percentage up by changing my random number generator so that about 25% of my tiles are going to be my new, my actual level. And so as part of this, I'm going to run into issues. There's a weird bounding box there. Some issues here where I could theoretically have an issue where my goal gets generated in a spot that I can't actually get to. There are a couple of ways around this. The way that I'm going to show you is fairly simple, but it does do the job rather well. What I'm going to do is I'm going to create a way to trace from my 1-1 tile all the way through my map. And I say map here, but what I mean is my auto-generated level. When I get to what I want is I want to figure out what all of the tiles are and what things are reachable from 1-1. This could take a little bit of time, depending, but there's some really, really great things about this. So I generate the level, and then I start to draw out stuff using BFS, right? Using my breadth first search. And what I want is I want to identify eligible, visitable tiles for my placement. And then put my goal tile in one of those spots. All right. So how do we accomplish this? And just a brief thing, you should remember breadth first search from the stuff from 201, but if you don't, if you think of your level as a big giant graph, a grid, I'm going to start in the top left, and I'm going to be looking at its neighbors. And then I'm going to deal with all of the neighbors of 1-1, and then starting with, the leftmost neighbor, if you will, I'm going to look at all of its neighbors, and then visit all of those, and then so on and so forth. And this way, it sort of comes out from the diagonal. So it just sort of peppers through here and flows through this sort of naturally. And it figures out everything that I could actually visit. Okay. So, first thing I'm going to do is I'm going to create another table. I use tables a lot in this. Tables are quite handy for this sort of thing. And then in my generation, in my actual level here, I'm going to create a second level of my visit. And then I'm going to do a third level. So what I want is I'm going to basically create this grid of X, Y values. And so as I'm going through this, I'm basically saying, okay, I'm peppering through all of my possible spots. So what I want here is I want visit ijx is equal to I. Visit ijy to be j. And then I'm going to actually create another flag here. Visit ij.v is equal to 0. So what am I actually doing here? In this part, I'm basically creating a two-dimensional array of x, y values where each spot is one of the tiles within my 14 by 14 grid. And so in those, I'm going to have a flag. And I'm going to set that flag initially to be 0. And then as I'm going through here and actually generating my wall pieces at this point, I'm going to note that those ij positions as a 1. 0 means that this is a space that I've got, and 1 means that it's a space that has something in it already. I'm going to use another flag here a little bit later to actually handle my breadth first search. But what I needed to establish initially is this 14 by 14 grid that I'm actually going to go through. If you want to think of this as actually creating a encoding of the graph that is the grid, that's probably okay. Where the 0 elements are empty spaces in my grid, and the 1 element, the elements that are flagged 1, have walls in them. All right. Now, I need to actually do my breadth first search. So in here, I'm going to create a queue. If you remember from 201, the way that you do classically breadth first search is to either use any of the searches is to use either a queue or a stack, depending if you want to do depth first or breadth first. So in this case, because we're doing breadth first search, we're going to use a queue. I'm going to name the queue R. And so R sub 1 is equal to visit 1, 1. I need to start with the head node, which is basically the root that I'm going to start from. The place that I need to, my source node, if you will. I'm going to set that value of that head node, visit 1, 1, to be equal to 2, meaning that I have visited it and it is on the queue. Now this is where things happen. While pound R does not equal 0, do. What does pound R do in this case? Well, it basically gets me a length of my table. So it tells me how many things are in my queue. As soon as my queue is empty, I want to stop. Set up a temp variable here, which is just going to be the very first element of my queue. This needs to be R. And then I'm going to actually delete that element off of my queue. And when I actually pull R1 and then delete it, it shifts everything over. When I add things to my table, it adds to the end. So I actually get my first in, first out behavior that I want. Now I need to do some checks. So if temp.y is less than 14, then if visit temp.x temp.y pulls from that that value there, dot v, so I need that visit value, is equal to 0, meaning that I haven't been here yet. Then update that value, temp.x temp.y dot v is equal to 2, and then add that value to the queue. Add that visit element to the queue. Queue visit temp.x plus 1 temp.y. No, shoot, I screwed that up. Temp.x temp.y. Looking too far ahead here. Oh no, I do want this. I want temp y plus 1, temp y plus 1, plus 1. I need to know from my element, since I'm moving basically out, I need to know what the element directly south, if you think of it in cardinal directions, and the element that's east. And then I need to add those to my queue. But only if they haven't been added yet. So if visit looking south is 0, then add that stuff. And that check, and that check. If temp.x is less than 14, do the same thing, but with the x coordinate. If visit temp.x plus 1 temp.y dot v is equal to 0, then visit temp.x plus 1 temp.y dot v is equal to 2. Again, flag it as I'm here, add it to my queue for processing. There we go. And end. All right. Now, we should be all set here. What this will do is it'll consistently find things that I can actually reach that aren't walls until I can't get to anything more. Great. Now that I've got this information, all of these visit ij's, xy's if you want to, that are 2's, then I need to actually use that information in some way. Okay, so in my generation of my goal, back up here in gen level, right here. I don't know why I went so far. I'm going to actually need to change this a little bit. I'm going to change this so that it's a little bit farther out. So we're going to do 9 and 5 here. And I'm going to say, okay, so I've got my k is equal to true. I'm going to generate my ij. Set k is equal to false. To basically prime the pump here. And then say, for Q and all tiles do blah, 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 blah. My usual thing here. So for what I want is I actually need to change this slightly. So for Q and all tiles, what do I want now? What I want is if my... I need to turn this true back on. So if I generate something, so if I is equal to q.x and j is equal to q.y, then I need to turn the trigger back on. So k is equal to true. But I also now need to check if that isn't true, come out of my while loop. Do I want it out of the while loop? No, I want it actually in the while loop. And I need to check here. So I've gotten the all clear that I and j are fine. They aren't one of the tile pieces. I need to check here that I and j are actually visitable. All right. So if visit I j dot v is not equal to 2, then k is equal to true. Fantastic. Okay, so once again, up here, I did a breadth first search. All this code here does a breadth first search. Establishes what tiles are visitable from 1-1, from my 1-1 tile. Down here, I generate I and j, and I'm generating them slightly larger so that I have plenty of spots, and I'll talk about why that might be a problem, why there's a problem that goes with this. I flipped this for loop so that I made sure that I had multiple places, because I need multiple places to check. I have this check to make sure that ij isn't one of the wall tiles. And then I have this extra check here that makes sure that it's visible. If it's not visible, or if I and j happen to be a wall tile, then I needed to generate ij again. Okay. Now, hopefully I didn't screw anything up here. I've screwed something up. Well, one thing that I definitely forgot here is I need to actually set up goal here. So goal.x is equal to I called y is equal to j. Alright, so here's the problem. I have q here, except I don't need q here, I need r here. Fantastic. Now, save this, go back, load, run, and voila! We now have something that works. And note a couple things. One is we won't get trapped, and we won't have an issue with sort of plain non-interesting levels. Alright. There is one small issue. There's a other than the colliding thing. There is an issue where if it happened to be that you had a perfect border such that I have it set up so that it basically goes from tile 5-5 down across to 5-14 and down to 14-5. The 14-5? No. Down, so from 5-14 and 14-5 all the way down to 14-14. That any of those spaces could have the goal. If it just so happened to generate a level, it's a very, very rare chance, where you could not get to any of the elements that are in that border, then this would actually spin to infinity. And it would just never, it would never generate. This would not be great for sort of production level code. So you would need to build in one of two things. One is a rule check to make sure that whatever you had, that there was at least one tile that was visitable that was in that range. It's a simple for loop. Well, it's a double for loop, but easily doable. And if it happened to be that that was true, then he would just regenerate the level completely. Just run gen level and then break out. The other option, and this is far more complicated and sophisticated, is to actually work back from the bottom right corner and delete elements until you actually had a space. So that whatever tile, you would just choose a goal tile and then work backwards back to 1-1. And if you couldn't get to 1-1, you would actually delete wall spaces as you went along. This sort of reverse maze generation is something that's used a lot, especially, again, for creating mazes, and can be used in this case as well. So there's another thing that's kind of missing here. We have no enemies. And so if I wanted to add in enemies, I'm not going to do this now because, again, we're running a little long. What I would want to do is actually generate those with enough space, possibly using that Manhattan distance function that we did in the AI. Again, on visitable spaces, and have them enough distance away, and then have them chase, right? At which point, you can get them stuck on wall corners and stuff like that, and make it an actual game. As the levels progress, you could have them speed up. You could have more of them show up. You could have them be placed closer to the actual player based off of, you know, a simple rule. Again, procedural generation is all about rules. A simple probability rule that states the higher the level is, the probability is higher that it'll be close to the player. All of these things are definitely possible. If you take the stuff that I did today, again, I'm going to post this a little bit later. The stuff that I did today, the stuff that I did for the AI lecture, put it together, you actually have a halfway decent game. All right. So let's talk about homework. So homework and this homework will be due on the Monday that I get back. I would like to know what your favorite board game mechanic is. So, Monopoly, Trouble, Pandemic, Settlers of Catan, whatever board game mechanic you like best. I want examples of where that mechanic exists, and I want to know why. So a simple one paragraph, few sentence write-up, print it out, bring it to class on Monday. As always, during the class periods, I will be available on Slack. So just drop me a note on Slack, either in the 438 group or through the direct message system. And I'm happy to answer any questions about this or about the major project stuff. And again, I will see you in however many days until that Monday comes around.